Welcome back to Dead Reckoning, the Human Life Expectancy channel. Today we'll describe one of mankind's most spectacular achievements, how we managed to double human life expectancy. However, before we solve this mystery, we have to define what human life expectancy is. Life expectancy is simply the number of years a person born today is expected to live, something that population scientists call life expectancy at birth. We'll refer to this as simply life expectancy, or HLE, for human life expectancy. For a population of people that can be observed from birth until death, HLE is defined as the average age of death. However, more commonly, you can't observe a population from birth to death, and you have to estimate the life expectancy of an existing population. In this situation, statisticians and actuaries use what's known as the cohort approach. This approach follows each group, or cohort as actuaries say, of people from the same age and sex throughout its lifetime, exposing it to age and sex-specific mortality rates that are commonly quoted as deaths per 100,000 people. The first person to do this was British mathematician Benjamin Gompertz. In 1825, he calculated the risk of death for people of different ages in order to determine how much to charge for life insurance. He found that the rate of death doubled every 7 to 8 years of life between 20 and 60, which is the relevant age for most people to buy life insurance, and then levels off. This largely still holds true today and is known as the Gompertz equation. Our calculations modify death rates based on new technologies and advances and use the cohort approach to produce our dead reckoning estimates of how HLE will change going forward. Also, there's 4 things we have to clarify about HLE. First, HLE is not your personal life expectancy. Your individual life expectancy is determined by your genetics, your behaviors, and many other factors that we'll discuss in future videos. Your individual life expectancy also gets longer as you age. Every year that you manage not to die means that you out-survived those who did not, and therefore can expect to live longer. So for example, an average 50-year-old in the US can expect to live to an age of 81, and the average 75-year-old can expect to live to 87. So if you're 72, you generally needn't fear dying by the global HLE of 73. Next, HLE is highly sensitive to the rate of infant mortality. Reducing or eliminating causes of death that impact babies and children, such as birth complications, has a much greater impact on life expectancy than reducing those that impact older people, such as Alzheimer's. In addition, populations with low HLE might still have plenty of older people. Countries with low HLE often have high rates of infant mortality, but those who survive infancy often have much longer life expectancies. In previous centuries, despite much lower life expectancies, 70-year-olds weren't rare. Galileo Galilei died at age 77, Isaac Newton died at 84, and Michelangelo lived to the ripe old age of 88, all without the help of antibiotics, vaccinations, organ transplants, or any other modern medicine. Finally, HLE does not reflect the quality of life or maladies that do not result in death. And to state the obvious, quality matters. As Benjamin Franklin wrote, "A long life may be good enough, but a good life is long enough." While health span and lifespan are highly correlated, concerns remain that we might live longer in ill health. To account for this, there's other metrics that are used, including health span, quality-adjusted life years, health-adjusted life years, and disability-adjusted life years. So, with all those points out of the way, let's now solve the mystery of how we doubled HLE. Since the beginning of time, our species has been in a fight against nature for survival. Weather, natural disasters, predators, disease, famine, all those things seem determined to kill us. It's worth noting that we came perilously close to losing this battle. Homo sapiens almost went extinct 70,000 years ago after the eruption of the Toba supervolcano in Sumatra, when the human population fell to about 1,000. However, over the eons, our species had struck a stalemate with survival, with archaeological forensic information indicating that HLE remained between 20 and 30 years, up until the year 1500. During this time, multiple plagues, such as smallpox and the bubonic plague, reduced our populations, causing HLE to drop. Deaths from wars also reduced the population and HLE, but varied between 2 and 100 deaths per 100,000 people per year. Compare this for reference to the death rates for heart disease currently of about 150 deaths per 100,000 people per year. From the 1500s onward, we have actual data on human life expectancy. Data from the United Kingdom shows that HLE between 1500 and 1900 varied between 22 and 42 years. It may seem odd that all the advancements of human civilization up through 1900 basically added nothing to the life expectancy of our species. In short, many of the advances we made with tools, fire, bow and arrows, shifting to an agricultural society, etc., were all offset by increased disease transmission by living closer together in cities, periodic famines, and war. In 1843, William Farr, a doctor and statistician that led the collection of public health statistics in England and Wales, produced life tables for London, the industrial city of Liverpool, and the rural city of Surrey. His analysis clearly showed that while the rural city of Surrey had an HLE of almost 50, London had an HLE of 35, and the industrial city of Liverpool had a dismal HLE of only 25. This was the first known quantification of the reduction in HLE associated with early industrialized economy, but it wasn't the last. After that time, early industrial economies around the globe commonly experienced decreased HLE as people left their agrarian lifestyles for crowded urban slums, which greatly facilitated disease transmission and resulted in extraordinarily high rates of infant mortality. Conditions deteriorated even further for the proletariat during the Industrial Revolution as work days lengthened, as hygiene, health, and pleasures diminished. Overall, peasants had to work harder than foragers to eke out a less varied and nutritional diet, and they were far more exposed to disease and exploitation. Historian, geographer, and author Jared Diamond called the move from hunter-gatherer society to the agrarian society the worst mistake in the history of the human race. And historian Yuval Noah Harari described it as, quote, the biggest fraud. Maybe we missed out on something here. However, despite plagues, wars, and exploitation, low HLE during this period was largely due to high rates of infant and child mortality. Once people made it past childhood, their prospects for a long life were good, with 21-year-olds reaching an average age of anywhere between 62 and 70 years. Then, starting around 1900, HLE began to increase in what Nobel laureate economist Angus Deaton called the Great Escape from HLE's historical maximum of about 35 years. The reduction in child mortality was a primary driver of the increase of human life expectancy, but what was allowing children and adults to live longer? Key advances in science, medicine, and technology starting in the mid-1800s made this possible. Advances in food, water, and energy technologies resulted in more secure and sanitary supplies of food and water, and more safe and ubiquitous supplies of energy. In addition, 4 big medical advances in the mid-20th century significantly increased HLE: the development of vaccines, pasteurization, antibiotics, and public health. Vaccines have been called the single most effective medical intervention in human history, but they took hundreds of years to come to fruition. Throughout history, smallpox has been one of the deadliest plagues facing humanity. It's estimated to have killed around 500 million people in the last 100 years of its existence, and 300 million in the 20th century alone. As recently as 1967, 15 million cases occurred a year. For comparison, this is over 10 times the number of deaths due to coronavirus in 2020. Those who contracted smallpox experienced fever and vomiting, followed by ulcers in the mouth and a skin rash which turned into a characteristic fluid-filled blisters with a dent in the center. The bumps then scabbed over and fell off, leaving scars. Ultimately, smallpox killed about 30% of those who were infected and up to 80% of babies who were infected. By the 1600s, the Chinese, Indians, and Persians all knew that those who had already had smallpox were much less likely to get it again, and they began practicing an early form of vaccination called variolation. Variolation involves direct exposure to small amounts of harmful viruses, for example by blowing powdered smallpox scabs up the noses of the healthy. And this induced immunity. Different from modern vaccines, which use innocuous agents that are similar to virulent diseases to provoke an immune response, variolation gave healthy people the virulent diseases themselves. While this commonly resulted in less serious cases of the diseases and resulted in immunity, at least for a period of time, they also involved death rates among healthy people that, while far lower than those of the naturally occurring diseases, would be considered unethical and unacceptable by today's standards. True smallpox vaccines weren't developed until 1797, when Edward Jenner, having noticed that dairy workers that had contracted a less dangerous form of smallpox that attacked cows, called cowpox, seemed not to get smallpox. And he inserted some pus from cowpox blisters into incisions of healthy patients, causing them to be immune from smallpox. This advance of using an agent that resembles a disease-causing microorganism to trigger an immune response became the core idea behind vaccination. The word vaccination itself comes from Latin variole vaccinae, smallpox of the cow. Vaccination also reduced the mortality rates involved with variolation. In 1857, Charles Dickens wrote, quote, "Few thoughts have given more material benefit to man than that which arose in Dr. Jenner's mind when it occurred to him that by putting intention in the place of accident, the benefit of exemption from smallpox might be extended." Despite these clear advantages, it took decades for the smallpox vaccine to gain global distribution and adoption. Producing the vaccine in volume and delivering it globally was the first major challenge. However, overcoming resistance and establishing regulations to enforce mandatory smallpox vaccination proved even more difficult. In the mid-1800s, anti-vax movements arose in England and the US that closely resembles today's anti-vax movement. Based variously on the premises that vaccines interfered with God's will and that mandatory vaccination overstepped the state's authority over individual liberty, such groups greatly slowed the implementation of life-saving smallpox vaccines, resulting in millions of unnecessary deaths. It took decades for people to appreciate the level of carnage, to understand that they could do something about it, and to overcome unfounded fears and vested interest to realize this change. In addition, it took until 1965 for the World Health Organization to undertake the ambitious goal of eradicating smallpox globally. With sustained, coordinated action across countries, this goal was finally realized in 1979, marking a triumph for medicine and for humanity. After the smallpox vaccine, vaccines for whooping cough, tuberculosis, diphtheria, and polio followed. Today, the WHO lists 30 vaccine-preventable diseases, including COVID-19. The second major advance was pasteurization. In 1862, people, especially in the cities, were dying from drinking spoiled milk, which was being shipped without refrigeration from the country. Louis Pasteur had observed that microbes were proliferating within the unrefrigerated milk. This discovery laid the groundwork for the germ theory of disease, the understanding that bacteria and viruses were behind many of the diseases that plagued humanity. He also discovered that by heating the milk to 130 degrees Fahrenheit and quickly cooling it again, these microbes could be killed in the process, which what we ultimately named for him and now call pasteurization. Despite the extraordinary life-saving efficacy of this advance, like the smallpox vaccine, pasteurization took decades to be adopted globally. At the time, international health efforts were sparse and uncoordinated, greatly slowing the spread of knowledge that pasteurization could save lives. And once again, many viewed the deaths as God's will and inevitable despite information to the contrary. In addition, dairy companies were slow to voluntarily incur the cost of pasteurization equipment, especially because many customers believed that pasteurization hurt the taste of the milk, and they incorrectly believed that it made the milk less nutritious. In the time it took for people to realize that pasteurization could save lives and clear up the misinformation on pasteurization, millions had died across the globe. Eventually, since so many people, especially children, were dying from tainted milk, in an early example of dead reckoning, Sir Frederick Teaves of the National Health Society of London, England, wrote, "The absolutely reckless use of raw, unpasteurized milk is little short of a national crime for which we are paying heavily in ill health, disease, and death." By 1913, this thought had made it to the US, where Nathan Strauss, part owner of the Macy's department store in Manhattan, lobbied the US Congress to enact regulations requiring pasteurization. He wrote, quote, "The only safe rule is to require the pasteurization of the entire milk supply and make it a function of the municipality." While it took half a century for pasteurization to become common practice globally, it continues to save millions of lives today. The third great medical advance was the development of antibiotics. The germ theory of disease eventually led from vaccines to curing infections that already had been contracted. In September 1928, Scottish scientist Alexander Fleming discovered that a blue-green mold that he had accidentally let grow in a petri dish of Staphylococcus bacteria actually stopped the bacteria's growth, and the first antibiotic was discovered. The first antibiotics were prescribed in the late 1930s, beginning a great era in discovery, development, and prescription. Once again, it took decades for penicillin and other antibiotics to be fully and scientifically proven, to be made economically and culturally viable, and required for use around the globe. Once again, there was resistance from those who felt that death from smallpox and other diseases was God's will and inevitable, despite the information to the contrary. However, as antibiotics gained acceptance, bacterial infection plummeted as a result of death. In fact, between 1944 and 1972, global human life expectancy jumped by 8 years, largely due to the global introduction of antibiotics and vaccines. The fourth major advance was public health. Since diseases are often more easily prevented than cured, in the mid-1800s it was discovered that identifying trends in mortality data could be a life-saving tool in itself, and the science of epidemiology was born. In addition to William Farr's report of 1843 we mentioned earlier, in 1854 a cholera outbreak in London caught the attention of Dr. John Snow. He constructed a map of the outbreak that showed that a water pump at 40 Broad Street was the source of the outbreak. By simply removing the handle on the pump, thousands of lives were saved, all before the biological causes and mechanisms of cholera were known. Since then, the science of epidemiology has used health data to think systematically about outbreaks and plot their distributions over space, and has greatly contributed to the increase in global HLE. Public health also advanced after the discovery of the germ theory of disease in 1894. Public health advancements include improved sanitation, public water treatment, sewage management, quarantines, food inspections, and municipal garbage inspection, which all greatly reduced the rates of death from infectious diseases. Also, other social advancements such as greater understanding of nutrition, better housing conditions, air quality improvements, child labor laws, and higher literacy rates also greatly improved overall health and life expectancy. HLE was also greatly enhanced by organizations that were founded to promote health. In the early 20th century America, there were almost no prohibitions on the pharmaceutical industry, and much of the medicine of the US market was either ineffective or actively harmful, such as leeches, arsenic, and mercury. In June of 1906, responding to widespread adulteration and misbranding of food and drugs in the United States, President Theodore Roosevelt signed the Pure Food and Drug Act, which was known as the Wiley Act, and that established the USDA's Bureau of Chemistry to enforce the act. However, subsequent judicial decisions weakened the Bureau's power significantly, allowing multiple injurious products to be sold, including radioactive beverages, a mascara called Lash Lure which caused blindness, and worthless cures for diabetes and tuberculosis and other diseases. In 1927, the Bureau of Chemistry's regulatory powers were reorganized under a new USDA body, the Food, Drug, and Insecticide Administration, and that name was quickly changed to the Food and Drug Administration, the FDA that we know today. On June 24, 1938, President Franklin Delano Roosevelt signed the Federal Food, Drug, and Cosmetic Act into law. The new law significantly increased federal regulatory authority over new drugs by mandating a pre-market review of the safety of all new drugs, as well as banning false therapeutic claims in drug labeling without requiring that the FDA prove fraudulent intent. Soon after the passage of the 1938 Act, the FDA began to designate certain drugs as safe for use only under the supervision of medical professionals, and the category of prescription-only drugs was securely codified into law by the Durham-Humphrey Amendment of 1951. After World War II, on April 7, 1948, the World Health Organization, WHO, was established as a specialized agency of the United Nations. Its main objective is the attainment by all people of the highest possible level of health. It advocates for universal health care, monitors public health rules, coordinates responses to health emergencies, and promotes human health and well-being. It provides technical assistance to countries, sets international health standards and guidelines, and collects data on global health issues through the World Health Survey. Its flagship publication, the World Health Report, provides expert assessments of global health topics and health statistics on all nations. The WHO also serves as a forum for the summits and discussions on health issues. The WHO has played a leading role in several public health achievements, notably the eradication of smallpox, the near eradication of polio, and the development of an Ebola vaccine. Its current priorities include communicable diseases, particularly HIV/AIDS, Ebola, COVID-19, malaria, and tuberculosis, non-communicable diseases such as heart disease and cancer, healthy diet, nutrition, food security, occupational health, and substance abuse. Then, in the late 1940s, a methodological breakthrough, second only to the development of the scientific method itself, allowed us to prove the efficacy of drugs for the very first time. Medical researchers began to use randomized controlled trials, or RCTs, to test the risk from pollutants and the efficacy of new treatments. In a randomized controlled trial, subjects are divided randomly into two groups. The experimental group receives the treatment or intervention to be studied, and the control group receives either a placebo or nothing at all. This experimental form allowed scientists to collect data and apply statistical approaches to empirically determine whether drugs actually worked or whether pollutants actually caused harm in a completely unbiased way. In the 1960s, this allowed the U.S. Congress to pass the Kefauver-Harris drug amendments, which for the first time required drug companies to provide proof of efficacy. RCTs were used to prove the detrimental health effects of smoking and to assess the efficacy of new pharmaceuticals and medical approaches. For example, just within cardiology, new procedures were developed and new pharmaceuticals, including statins to lower LDL cholesterol, clopidogrel and warfarin to prevent blood clots, beta blockers and ACE inhibitors to treat heart attack and lower blood pressure, and all of these pharmaceuticals significantly reduced mortality. As great as these four big advancements were, our focus on dead reckoning requires that we emphasize that they could have occurred more quickly. The fact that it took vaccines, pasteurization, antibiotics, and public health efforts decades to be fully utilized highlights the point that having a good idea or a scientific or medical breakthrough isn't enough. In order to have an impact on global HLE, a new technological and medical advancement must be scientifically proven to save lives, but it also has to be economically, ethically, and culturally viable, and it has to be driven by regulations that require its use. So, if we agree that extending HLE is a good thing, then we have to say with equal certainty that failing to do so is a bad thing. In that light, a simple dead reckoning calculation shows that the decades of time it took us to fully adopt vaccination, antibiotics, and pasteurization cost us hundreds of millions of lives. This brings us to a central theme of these videos, which is that ignorance and misinformation are actually much greater killers than malice. We'll show in future videos that due to stronger health administration, accepted standards for scientific proof, almost instantaneous communication, and robust global supply chains, there's good reason to believe that similar advances today would improve global HLE far more rapidly. It's ultimately ideas that cause us to live longer. The idea that a vaccine can prevent future infection. The idea that germs in our milk that kill us can themselves be killed. The idea that some things cause bacteria to stop growing. The idea that studying patterns in mortality can help improve public health. The idea that smoking kills us, and on and on. These are just some of the thoughts that have been scientifically proven and that most of us have now adopted to the benefit of mankind. This leads us to ask, what's the next tranche of thoughts that will extend our lives? How about the thought that extending HLE should be recognized as a goal of humanity and hotly pursued? Or how about the thoughts that climate change, our eating behaviors, and our sedentary lifestyles are killing us? Or the thought that aging can be cured? Or even the thought that our genomes and epigenomes can and should be modified to our benefit? These are just a few of the potential thoughts that we'll explore. Now that the scientific method is established, the main thing we need is to change people's minds. A central hope of these videos is that they accelerate our thinking so that we can save millions of lives that might otherwise be lost if we once again allow our minds to wander or to be misled from the objective of enhancing global HLE. The dead reckoning perspective suggests that saving and extending all lives that we can should evoke the same powerful motivation that we have to fight terrorists or anyone attacking our families. Whether they're killed by violence or by failing to save or extend their lives, all dead people are equally dead. We seek to extinguish ignorance, eliminate false distinctions in how we die, and spark new thoughts that will light our way to increased HLE going forward. So after millennia of minimal progress, global HLE has more than doubled since 1900. That's an extension of approximately 4 months for every single year. This is a truly unprecedented achievement, and you'd think we'd never stop dancing. As we'll see, HLE is set to accelerate even more quickly in the future due to many new technologies and medical advances. In our next video, we'll focus on the things that kill us today and how they're changing. In the meantime, please hit the like button below, subscribe to the Human Life Expectancy channel to make sure you don't miss our next videos, and post comments for the topics you'd like to have us cover. Thanks for joining us. Till next time, as we say at Human Life Expectancy Inc., hi hua! Please, do what you can to help yourself and help us all to live longer.